in question number 7 it says, in a laboratory investigation, a 50-gram sample of copper is at 100 degrees Celsius in a boiling water bath. A styrofoam cup with a lid is used as a calorimeter. The cup contains 100 grams of distilled water at 23.2 degrees Celsius. The hot copper is poured into the cup of water, and the cup is quickly covered with a lid. The thermometer is inserted in the lid. The copper and water are gently stirred in the cup. The temperature is checked periodically. The highest temperature is 26.3 degrees Celsius. So the first thing we will kind of want to do is we want to draw a picture of what's exactly going on here. So we know that we have some copper and it's hot. So they said it's in a water bath, so it's 100 degrees Celsius, and we know that this is a 50-gram sample. And then this copper is added to a cup of water. Now, this cup of water is 100 grams of water, and it initially is at a temperature of 23.2. And what we're going to do is we're going to take the hot copper and put it into the cold water. After this addition, they again tell us that the water then gets to 26.3 degrees Celsius. The first question asked, in terms of energy, why is the temperature of the water increasing? Well, the temperature of the water increases because, remember, in terms of energy, heat energy is flowing here, and heat flows from hot to not. So here, heat is flowing from the copper from the hot copper into the cold water. The next question asks us to show the correct numerical setup for calculating the amount of energy in joules absorbed by the water. So again, let's look at our water. We have 100 grams of water, initially at 23.2 degrees Celsius, and then it gets hotter. So the temperature of the water changes. So for this equation, we're going to have to use the Q equals mc delta T equation found on reference table T, because the temperature is changing. So when we look and see from our diagram, what do we know? We know that we're only concerned with water here, that the water's mass is 100 grams. We also know that the water's initial temperature, which I'm going to call T1, is 23.2, and its final temperature, which I'm going to call T2, is 23.6. Recall from earlier that whenever we're using this equation, or any heat equation, one of the variables has to come from your reference table B. And that, in this case, is going to be the specific heat capacity. That value found on reference table B is 4.18 joules per gram degree Celsius. So if we substitute into this equation, again, we're looking for Q. We know that M is 100. The specific heat is 4.18, and then we'll need to find the change in temperature. So here, our change in temperature is 3.1. I simply took T2 minus T1. Now this is the correct numerical setup. In this case, it doesn't tell us to solve, so we can stop here, and that will suffice. The last question is a simple vocabulary question which asks, in which process does a solid change directly into a vapor? It is important that you're familiar with the names of all of the pertinent phase changes between the three states of matter. So we have solid, liquid, and gas. And if we add heat, which we'll symbolize with red, as we change from a solid to a liquid, that is going to be melting. In chemistry, we may call this fusion. So it could be said either way. When we change from a liquid to a gas, that is called vaporization. So that's to vaporize. It may also be called boiling. And then if I have a solid and I add heat to it and it turns directly to a gas, that is called sublimation. Now, so that is the answer to this question, but we should also review the phase changes that are exothermic or occur with the removal of heat. So if I have a gas and I remove heat and it turns directly into a solid, that is called deposition. So that is to deposit. If we have a liquid and we turn it into a solid, that is called freezing. Sometimes that can also be called crystallization. And when I have a gas and I turn it into a liquid, that is called condensation. So for the next question, we can refer back to the diagram we drew on the previous slide, and it asks which phase change is exothermic. So this keyword exothermic refers to the fact that heat will exit, meaning it's getting colder. So our exothermic phase changes were drawn here in blue. So in this case, our exothermic phase changes would be condensation and deposition. Just as a refresher, please note that all of the other phase changes, the ones pictured here in red, are endothermic, or they require the addition of heat to occur. In the next question, we're asked to refer to the heating curve provided, and it asks, during which line segment would fusion occur? So the key word here is fusion. Now fusion, which is the chemistry way of saying melting. So remember that in a heating curve or cooling curve, that phase changes always happen at the plateaus. And here we have all three states of matter because we have three sloped lines. So melting would occur between the solid and liquid state. So in this case, that would be line segment BC. The other line segment DE, is a phase change, but that represents boiling or evaporation. In the next question, we're asked to examine line segment CD. So line segment CD is this sloped line here. And in this sloped line, basically we can see that we're asked about the kinetic energy. Now kinetic energy, or the average kinetic energy, is the same thing as the temperature. So essentially the question is asking what is occurring with the temperature. So we can see that the temperature is increasing. And while the temperature increases, recall that only one energy changes at a time, the potential energy, which is called the phase energy, the potential energy is going to be constant. So 3 here is our best choice. So just recall that kinetic energy is the same thing as temperature, and the potential energy is the phase energy, or how many phases are occurring. The next question asks us to explain why one substance, in this case fluorine, could be a gas, while another substance, which is iodine, could be a solid. And remember that what holds the shapes or the particles together in their phases is intermolecular forces. So we know that a gas has no intermolecular forces, while a solid has really strong intermolecular forces. So that means that the gas that has no intermolecular forces has really weak intermolecular forces. So choice 1 would be the best choice. Finally, we're asked to find an exothermic process. The word exothermic means that heat exits, or the phase is getting cooler. So if I change from a solid to a gas, the phase must get warmer. We have to add heat, so it can't be the first choice. If I change from a gas to a liquid, then I must remove heat. So the second choice is the best answer. The third choice, changing from a solid to a liquid, will have to add heat, so that's not very good. And then the last choice, gas, a liquid to a gas, again, you have to add heat. So the only choice where we actually have to remove heat or cool the phase is to change from a gas to a liquid or condense. In the next question, we're asked about the average kinetic energy, which we can recall is the same thing as the Kelvin temperature. So let's replace the word temperature in this question. The temperature of water molecules is greatest in which of these samples? So we're just looking for the highest temperature. So number 2 will be the greatest temperature. Notice that they're also giving us a mass. In this case, mass has nothing to do with temperature. So just be aware that this may be the case. It's almost like a way to make sure that you understand that average kinetic energy simply refers to temperature. In the next question, they ask about the particle arrangement that are rigid, fixed geometric pattern. Recall from the beginning of the review that fixed geometric pattern refers to a solid. So we're simply looking for a solid. Solids are symbolized with the subscript S. Again, we're still asked to look and examine and find an increase in average kinetic energy. Again, average kinetic energy is simply temperature. So we're looking for the segments that have an increase in temperature. And these sloped segments are experiencing an increase in temperature. So AB and CD are the two best choices that are provided. We also know that segment EF increases in temperature, but is not provided as an acceptable answer choice here. In the next part of the review, we're asked to simply complete the chart. So the first phase change is going directly from a solid to a gas. That is called sublimation. Now, if you start with a solid and you want to turn it to a gas, you must add heat. So that's going to be endothermic. The next phase change is going from a solid to a liquid. That is called melting. That may also be called fusion in chemistry. And we know that going from a solid to a liquid is actually not exothermic, but instead is endothermic. So that would be a typo. The next part, it asks to go from a liquid to a gas. To go to a liquid, from a liquid to a gas, we must add heat. So that is endothermic, and that is called boiling or evaporation. Finally, we're asked to describe sublimation yet again. In sublimation, what's going to occur is we're going to go from a solid state to a gas state. The first example of sublimation was the sublimation of iodine. The other substance that you must know that undergoes sublimation is carbon dioxide. So carbon dioxide sublimes, it goes straight from a solid to a gas state. Solid carbon dioxide is also referred to as dry ice. So all of the phase changes outlined here are endothermic.